So welcome back to example 2. We're going to use the sum to product identity to evaluate cosine of 15 degrees minus the cosine of 75 degrees. And our sum to product identities are listed here in this table. The difference of two cosines can be found at the bottom here, and that's -2 times the sine. And then the argument of that function, we add the angles and divide by 2. So we'll take 15 degrees plus 75 degrees divided by 2. And then that's times the sine. And then the argument of that function is to subtract the angles and divide by 2. So 15 degrees minus 75 degrees, all divided by 2. So as we simplify, we'll have -2 sine of 45 degrees. 15 plus 75 is 90, divided by 2 is 45. And that's times the sine of -30 degrees. 15 minus 75 is -60. Divided by 2 is -30. So now remember from our fundamental identities, sine is an odd function. So we can use an odd identity to take that negative angle and make it a negative sine of the positive angle. And then a negative times a negative is a positive. So this becomes 2 sine of 45 degrees times the sine of 30 degrees, using that odd identity on sine. 45 and 30 are special angles on the unit circle. So 45 degrees is at pi over 4 radians. The sine is the y coordinate at that angle, which is the square root of 2 over 2. So we're going to substitute square root of 2 over 2 for the sine of 45 degrees. 30 degrees is pi over 6 on the unit circle, and the sine is the y coordinate, which is 1/2. And these 2's cancel. Root 2 times 1 is root 2, and then we're left with a 2 in the denominator. And that would be the exact value. So the calculator cannot find that answer for us, that exact value, but we can check in the calculator by comparing the decimal equivalents for these two values. So we want to change from radian to degree mode, and we're going to evaluate the cosine of 15 degrees minus the cosine of 75 degrees. And then we'll compare that to the answer we got, which was the square root of 2 over 2. And we see that the decimals are equivalent, so we know our answer checks.